irrational numbers. What is irrational number? Means a number which is not rational is called as irrational number. Irrational number means a number which is not rational is called as irrational number, which means which cannot be written in the form p by q. Okay, q not equal to 0. This is one definition. And the another one, in case of decimal expansion, suppose if we have decimal expansion, that the decimal expansion of an irrational number will come like non-terminating. Non-terminating means it never ends, and non-repeating. Non-terminating and non-repeating decimals. That is called irrational numbers. For example, you take the division 22 by 7. If you take 22 by 7, what you will get? 3 7s are 21, carry over 1, decimal 0, 1 times 7 is 7, and then remainder 3, again 1 0, 4 7s are 28, 2, again 1 0, 2 times 14, then 6, again 1 0, 7 times 2 times 14 6 is 16 8 times 8 times 56, 4, again 1 0, 5 times 35, 5, again 1 0, 7 times 49, again 1 0, 1 time 7, then 3, again 1 0, repeating. No, it should not repeat. Oh, is it? Again 4 means 28, 2, 0, again 2 means 14, 6, 0, again 2, 8, 5, 7, 1, 4, 2, again 8 will come. Why it is repeating? It should not repeat. See, this is the value of pi we can take approximately. Approximately pi is equal to 22 by 7 will take. Why we are taking this much means, because this 3.14, right, that is the value of pi. Okay, so that is why we are approximating pi to 22 by 7, but not exactly 22 by 7. Also, we say pi is irrational. Pi is irrational because it has non-terminating and non-repeating decimal. The ratio between the circumference and the diameter is called pi, the value. Okay, so likewise, whatever the number comes inside the square root, like if square root of 2 is irrational, likewise square root of 3, if root p and p is prime, we say the number is irrational. In short, the number which cannot be taken out from the root is called as irrational numbers. Okay, also this follows a theorem. See, in this irrational numbers, I already said what is irrational number. What is irrational number? The number which cannot be written in the form of P by Q is called as irrational. In short, the number which is not rational is called as irrational. Also, if the decimal expansion of the given number is non-terminating and non-repeating, then we can say the number is irrational. Also, the numbers which comes inside the root, square root, which cannot be taken out, are irrational numbers. Okay. Non-terminating means it will not end. It goes and goes and goes on. Also non-repeating. Okay. Repeatings also it goes up to it goes and goes and goes on, but that will repeat. But the irrational numbers are non-terminating and non-repeating. Okay. So there is one theorem. The theorem number is what? 2.1 or 1.1 now? Yes, man. Non-terminating and non-repeating decimal. You want me to say the definition once again? The theorem 1.3 states that if P is prime, and P divides A square, then P also divides A. Simple. How we can prove this theorem? Proof and all not needed, just try to understand. See, if P is a prime number, the number A square can be written as product of P, like P1, P2, P3. We are not sure among which P is also one factor. Is it or not? Same way, if you write A, in that also the product, the prime factor P will come. Because when you say whole square means only this is squared, like the prime factorization of A is, if you say some P1 into P2 into P3 means, when you take whole square, what you will get? What you will get, man? Here square means, here P1 square, P2 square, P3 square, P square. So for this P square, P is a factor or not? Likewise, that P can divide this number as well as that number, vice versa. It happens. Okay. Now, we are going to prove root 2 is irrational. But sir, we already know root 2 is irrational. Why do we need to prove that? How that is irrational, that we need to prove. How it came. Okay. For that purpose, we need to prove that one. See, this result may help us. You just try to recall this one. We'll recall whenever it is required. So, example 4. Sorry, theorem 1.4. Root 2 is irrational. There is a proving method in math that works like, we assume the contrary first. At last we say we assumed wrong. Like we say, the method of going proof like that is the method of contrary. Okay, proving by contrary. Okay, or else proving by contradiction. So for that, let us assume that root 2 is rational. But we need to prove root 2 is irrational. I told you, no, the proof of contradiction, proof by contradiction. If it is not rational, obviously it is irrational. When we say it is not rational means all the other type of numbers will come. Okay. Then If it is rational means how this can be written? This root 2 can be written as P by Q, where Q not equal to 0. Also, this P and Q are co-prime. P and Q are co-prime. Meaning what? This fraction is in its simplified form. Fraction is in simplified form. For example, if it is not co-prime, what will happen? For example, 4 by 6, if it is, the numbers are co-prime or not? Not co-prime. So, this representation is not unique. It may change. Actual value is 2 by 3. So, we are taking this one. We are not giving any chance. So, that like co-prime numbers we are taking. Okay. And then, if you equate that, just cross multiply. Root 2 into Q is equal to P. Root 2 into Q is equal to P. Just cross multiplication. After that, squaring on both sides. Squaring on both sides. What happens when you square on both sides? You will get 2Q square is equal to P square. Mark this is equation 1. Why I am writing like this? You may think suddenly I wrote it is rational. After that this one. After that cross multiplication. See, we are going to try breaking this property. If it turns out that the numbers are not co-prime, then automatically our assumption is wrong. So, we need to get another factor except 1 for P and Q. So, that is why I wrote in this form. So, when you see this, it is evident that this P square is the multiple of 2. Is it or not? P square is multiple of, then we can say 2 divides P square. 2 divides P square. Because 2 is prime, 2 divides P square. Then 2 also divides P. Mark it like 2. See, we have found one factor of P other than 1. 2 is a factor of. Then we can clearly say that this P is also a multiple of 2. Is it or not? When 2 divides P, P is a multiple of 2. Once again I repeat, see. Since this P square is multiple of 2, we wrote 2 will divide P square. Based on the theorem, we wrote 2 will divide P. Now again we are going back reverse. P is a multiple of 2. What multiple? We don't know what multiple. Yes, okay. Then P is equal to 2C for some C. We don't know, it is some multiple. Also, this is from the theorem. We know the theorem, right? What is the theorem? From a known theorem, like I am writing. But in exam, you have to write from a known theorem that if P is prime and P divides A square, then P also divides A. Okay. To avoid confusion between this P, that P and this P means, you better represent this as A by P. But since we started by P by Q, let's go on like this. Now, mark this is 3. Substitute this 3 in 1. Then what you will get in place of P? What you are substituting? 2C square. That makes 4C square 2Q square. These two can be simplified and Q square is 2C square we can write. Now, you may get confusion. You should choose Q or P. Which is a multiple you see? Either C is a multiple of something of Q or Q is a multiple of something of C. No. Q is multiple of 2. This Q square is there, right? Okay. Also, we are about to prove that these two are not coprime. Okay. So, P we proved one factor. Then another factor is in need of is Q. So, we can say as Q square is the multiple of 2, we can say 2 divides Q square, and by the known theorem 2 also divides Q. Mark this is 4. See here in 2 we said 2 divides P means 2 is a factor of P. Here 2 divides Q means again 2 is a factor of Q. But see from 2 and 4, 2 is factor of P and Q. But this contradicts our assumption that P and Q are coprime. Why it is contradicting? Because initially we took a wrong assumption. So of course what we can say, therefore root 2 is not rational and root 2 is what? Irrational. Okay. Any doubts in this? Very important and easy question this one. Okay. Next, prove that root 3 is irrational. Do you know how to prove that? Shall I erase everything? No. Yes, man, important 5 mark.